If I could go back in time and tell the 20-year-old me about the life he was about to have, none of it would make sense.
Now, what about this internet thing? Do you know anything about that?
Sure.
Imagine a world where every word ever written, every picture ever painted, and every film ever shot could be viewed instantly in your home via an information superhighway.
500 days ago, we didn't even have Java. Now, the President and Vice President of the United States are quoting Java.
Well, today we're going to find out why Java, the software programming language, is such a big deal.
There was at no point where I woke up one morning and said, the world needs another programming language. It was more like, we're having these problems and the programming languages are getting in the way. In late 1990, early 91, we started a project at Sun to take a look at what was going with computing devices outside of the areas where the computing industry normally paid attention. At the very beginning, it was Mike Sheridan, Ed Frank, Patrick Naughton, and me.
They were basically Sun's top software and hardware engineers who had come together to create this revolutionary technology. Oak was the code name. James had named it. Story goes, looking out the window, first line of code, there's an oak tree.
I designed the language, I designed the runtime, I did all the original implementation, and that's what we used to build the prototypes.
Hello, I'm James Gosling, and this is Star 7.
One of the really pivotal things that happened was that Time Warner in, I think, late 92, put out this request for proposals for interactive cable television. And we were just so excited by this proposal and this apparently proactive, innovative cable company. The winner of the bid was announced, and not only was it not us, it was not anybody who had been in the original bidding. So that all fell apart, and there was this dark period that followed that.
We were failing, and I felt that failure squarely on my shoulders because my whole job was to make Oak ubiquitous.
Of the about 50 people who worked at First Person, about a third just quit outright. About a third sort of filtered back into Sun. And then there was a remaining of about a dozen people who didn't want to do either of those things.
We all got laid off, every one of us, including me. And then Bill Joy swooped in and said, no. And he managed to claw back a bunch of the layoffs. Then we started talking about how do we retarget this?
We realized we needed to return to first principles.
And it took a while for us to go, this internet thing, it's basically the stuff we've been working on for a couple of decades.
And then there was this magical moment when Mosaic, the first browser, was released. James and team downloaded it, realized we can rewrite the browser and bring interactivity to the web using Oak. Suddenly, it's not just about linking to text. It's not about static web pages. It's actually about bringing interactivity to the web.
Probably the hottest thing to hit the web since its initial explosion into public consciousness is Java, the new object-oriented, platform-independent programming environment from Sun Microsystems.
The HOTJAVA browser was really important because it made it a lot easier to demonstrate what you could do. People got really excited about having embedded content in web pages that wasn't static.
This is a web page. It's a web page on a PC. It could be on a Mac, on any other machine.
But stuff is moving.
Stuff is moving. An application is running locally here in the page. When I do this, it activates a 1,000-byte program that just moves that text.
Seeing, for example, a spinning Coke can and, Duke, our mascot, doing somersaults was mind-blowing.
That cube just looks like another dumb graphic.
But it's not. It's a program running locally. This is why Java is so important.
The timing of Java was a little bit of luck and a little bit of foresight. There were some elements at Sun that wanted us to go more slowly. And I had this really strong belief that if we missed this point in time, we're going to be in trouble. And it felt like we could fix the technology issues, but if we missed the timing window, we were in trouble.
Internet Explorer has a long way to go to catch up with Netscape. 3 out of 4 people on the web still use Netscape Navigator.
Netscape came to us and said, we need to do a release.
I cannot stress enough the importance of the Netscape deal, because even though Sun had a strategy for building a browser called HOTJAVA, nobody was using that, and it didn't exist. It wasn't out there at the time. So we had to get into, the big hot player browser. For anybody to write code to this thing and use it was going to require Netscape.
March 23, 1995, I will never forget the day that piece came out. The headline, which was above the fold, was "Why Sun Thinks HOTJAVA Will Give You a Lift." Everything changed after that. The floodgates opened. Everyone wanted to be part of what Java was enabling.
The release was really exciting, a real adrenaline punch. All hell broke loose.
I've often described 1995 as a full-blown success disaster. And what I mean by that is it was wildly successful beyond any of our imaginations, and our phones were ringing off the hook, and we didn't have the people in place to build everything that people wanted us to do. And
we quickly melted down Sun's internet. So we brought into our building a pirate T3 line. This was massively illegal, and we would have all been fired if this had been discovered. We were determined to succeed with this, and we were doing things that were, really on the edge to make it all work.
We were front page news, not just of the technical press, but of the business press and the mainstream press. And that was before 1.0. That was just people getting excited about the programming language and writing code and what they could see as possible with it.
I was traveling in Europe, and there was the JVM spec in a bookstore in Vatican City. I thought, wow, this is really wild.
It was also exciting and really a joy because I believed so much in what we were doing.
It was really glorious. I was so happy at the time.
In this page is a 2,000-byte three-dimensional representation.
The first sort of unveiling of Java was applets in browsers, and that was an important application, but it was just the very beginning.
Java is a phenomenal example of pivoting. We started experimenting with Java as an ability to use applets, but boy, did it take a turn.
In the mid to late 90s, web development was a patchwork of languages, right? There was all sorts of stuff, and we were really just duct taping everything together.
Programming always felt like you were tripping over your tools and working in a dirty workshop.
Programming was becoming complicated, and everyone was wasting lots of time writing their own data structures.
The dominant technology was the CGI bin interface, where people wrote little Perl scripts to do any kind of dynamic content.
There were a bunch of low-level languages like C. There were sort of takes on that, trying to go a little bit higher level.
A lot of the traditional systems were written in C or in mixtures of COBOL and C and these very heavyweight transactional processing frameworks.
Some people were using Perl, some people were using things like Cold Fusion, which nobody probably remembers anymore.
There was nothing that was kind of right in the middle that, had sort of the capability of doing low-level things, but also, high-level expressiveness.
We were hacking on Windows 95. That was the state of the art. And the cool kids, they were over on their, hand-compiled Linux.
Using C++ for creating a very large engineering application was extremely difficult task. We used to run into so many errors.
C++ in particular, while it did what people needed, it was hard, it wasn't fun.
If you've ever tried to debug a complex C program that does lots of storage allocation, it's a nightmare.
So in the 1990s, it's kind of hard to believe now, but software and hardware were tied together. So you basically would write an application, then you'd have to write a different application for another hardware platform.
If you were trying to write software that ran on IBM mainframes or Intel architecture machines or whoever, if you're a seller of software, if you don't have to do all of this work to port from one platform to the next, it's a very big deal.
Doesn't this really change the entire model for software distribution? I mean, once I write an app, it's written. I don't have to rewrite it for the Mac and rewrite it for this and rewrite it for that.
That's right. When it arrives locally, it arrives in a virtual machine on the Mac. It uses the Mac widgets. It uses the Windows 95 widgets. It looks Mac-ish, but it could be written once on a Sun or on any other machine.
Now, this was a terrifically difficult problem, and people will gripe about how well we did on it, but it was a kind of an audacious goal to say we were going to create a binary platform that would work anywhere.
I remember sitting there thinking, wow, I can write multi-threaded code once and it'll run on different operating systems.
The Java promise of being able to compile but then run in a variety of environments on a variety of form factors, whether it's this broad mobile ecosystem or set-top boxes or servers, has been a testament to the original vision of the creators of the Java language and runtime.
Java was this new little language that could be learned easily and allowed you to do so much more with so much less effort.
I believe that ultimately Java will be seen as a replacement for C++.
James described Java as a wolf in sheep's clothing. If you look at the feature set that Java had in 1995, it was kind of an eclectic mix that at first looked all over the map. You had a lot of somewhat risky, almost radical features like garbage collection and dynamic compilation and reflection and dynamic class loading. But there were also a lot of conservative, maybe even boring moves that were made. If you looked a little bit more closely, what you found was all of the risky stuff was happening in the runtime, and all of the stuff that was in the programmer's face was kind of boring, derived from C and Pascal and other languages. And this was a very deliberate move.
At some point, I realized that what I was really trying to do was sneak a few decades of academic research into an industrial setting. I wasn't trying to invent a programming language. I was trying to solve problems.
The radical features of Java were largely below the waterline. It was kind of like an iceberg. The part that was visible above the waterline was a relatively familiar, comfortable C-like language.
The whole decision to keep it looking like C or C++ was entirely a trick to kind of convince people that this was something familiar. You know, you show it to an engineer and they just understand what it does, because it looks like what they know.
And it was kind of like the mother of all Jedi mind tricks. Get people to adopt this somewhat radical platform while lulling them into a sense of confidence that, oh no, it's just like C, you're familiar with it, nothing to see here.
Many different application areas needed garbage collection and threads and dynamic class loading and all of this other stuff. But those things came in languages like Lisp and Haskell that were scary. So Java wrapped up those technologies in a familiar language. Looks kind of like C, kind of like C++, easier to understand, not some highfalutin fancy academic thing.
I like to call Java as C++ minus minus, because to me, coming in as a C++ programmer, It showed me how it can reduce a lot of complexities I have to deal with on a daily basis. So I didn't need to be convinced about Java. It clearly showed that I can be more productive programming in Java.
It was a language, as James often said, meant for the blue-collar working programmer.
What I meant was, it's a language for people trying to get stuff done. It was never meant as an academic language. Java incorporated a bunch of technologies that had been around for a long time, but they had just really never gained mainstream adoption.
It was definitely not the first language with a virtual machine, but it was one of the first very popular ones, and definitely first good one that got popular.
Knowing that Java can be used to implement the server-side code was a pivotal moment, and it completely turned the trajectory of where Java was heading.
It's kind of funny that Java managed to succeed the way it did, because originally the focus for Java was on embedded devices and Internet of Things, and that didn't necessarily pan out. And then Java pivoted from that to set-top boxes. It was only later that Java found a home on the server side and really took off, which was not on the radar at all when Java got started.
But one of the things that I really hadn't understood was just how much pain there was in the sort of enterprise software world of, building these large, complex applications.
There was a desperate need for something better. And, by luck, Java was the right thing at the right time.
In 95, C and C++ were pretty actively hostile to threading. And for a lot of complex problems, you really needed to have multiple threads so you could be doing more than one thing at once.
To have a language that had threading built in, that was network native, was really an eye-opener. It really changed what we were doing.
We'd have interactions with banks where they would have like a standard operating procedure of rebooting their systems every day. And there were lots of banks whose first experience with Java was like, it just keeps running.
I joined Sun in 1997 as a junior member of technical staff. And so it was actually kind of funny because the dynamic of the team, we had all these impressive, distinguished engineers and folks running around working on the big important specs. And then you had me, the little junior guy over in the corner, and I'm working on the servlet spec. Servlets really made web development sane for Java developers. You could plug this into any kind of server, and the server could do the job of translating what came over the wire into a request object. This simple model was a really powerful idea because it helped you bridge what was happening on web servers with databases or anything else on the back end. So it's kind of like the missing bridge between what was happening on the client and what was happening in the rest of a big enterprise system.
It gave a straightforward, standardized way for enterprise applications to be integrated into this large framework.
Microsoft Corporation today officially unveiled its Windows 95 computer program.
In 1995, the prevailing wisdom of the analysts and others was that all the wars between the hardware companies and Unix companies were over, that Microsoft had won that war. If you did not have a Microsoft strategy, you were dead.
In those days, people feared Microsoft. Everyone feared that Microsoft was going to leverage its dominance on the client side and basically become the sole platform.
Nearly everyone in the computer industry is afraid of Microsoft. Everyone, that is, except Scott McNealy, CEO of computer maker Sun Microsystems. His latest weapon in the drive to get Microsoft off their game is a product called Java, a new language used to write computer programs. Has Microsoft actually come after Sun?
Absolutely. We're probably ground zero right now.
We licensed the technology to Microsoft, and that was huge for Sun because it meant that Java was going to be included in every PC that shipped because it was in the operating system. Then we didn't have to worry about a strategy on that platform.
And the question was always, should we license with Microsoft? And we were very concerned about the implications of that. That seemed very risky to us. In the end, we did do a license with Microsoft. there's an email from Bill Gates to Nathan Myhrvold, the subject being the Java runtime becomes the operating system. And he says, I am worrying a lot about how great Java/Java Beans and all the runtime work they are doing is, and how much excitement this is generating. I'm literally losing sleep over this issue, since together with a move to more server-based applications, it seems like it could make it easy for people to do competitive operating systems. I'm very interested to get your thoughts on this. Prior to the advanced work you are driving, what kind of defenses do we have against this? I certainly haven't come up with enough to relax about the situation, and it is undermining my creativity. So that was Bill's concern in September of 1996. Not long after that, it became quite clear that Microsoft, in taking the license to Java, did not intend to follow the terms. Consciously intended to break the terms to try to embrace, extend, and extinguish.
When did you first become concerned about the competitive threat that Java posed to Microsoft?
The Java runtime activities are a competitive threat to Microsoft. Java itself is not. So if I use the term Java, that way I'm careful to make sure people know I'm talking about the runtime piece.
Microsoft was this constant presence in our heads, and the fear of how Microsoft would behave in the market factored into so many of our decisions in a way that was almost overbearing.
Microsoft has the power today to exercise predatory and exclusionary control over the very means by which we access this internet.
Early 1997, it became clear that they had released a version in their Windows operating system that was not compatible with the specifications as was required. They had not included a small number of APIs, and they had also added a couple of their own APIs. And so it was pretty clear to us that their purpose in that was to get people to write to the Windows version of Java and not do write once, run anywhere, and that in that way they would be able to take control of the technology, the APIs of the technology, the future of the technology away from Sun, and be in control of it themselves. Oh, this is really fun. So for one Java 1, in the middle of the Microsoft litigation, this t-shirt was made. I don't think it needs a comment.
This felt personal because we in the Java team had invested a lot in the model that we would make Java work by keeping all its implementations compatible. So we wanted to force Microsoft to either give up on Java or play the game the way we expected it to.
Sun at that time generally didn't file lawsuits. It wasn't the way the company operated. But once the lawsuit was filed, because compatibility was at the core of it, it took over my life for a couple of years, testing every version that they put out and figuring out where they had broken compatibility. The thing that became clear through the process of litigation and discovery is that we found an actual, what we referred to as the smoking gun email. Between senior people at Microsoft, there was an email that said, and I quote the first part, "Screw Sun." So it was very clearly their strategy, because they were the 800-pound gorilla with all the developers, to break the thing so that everybody would write to them, and then they were in control of it, and they were going to control the future of it. That was their play.
And I got sucked into all of the litigation stuff, just horribly.
A lot of Sun resources and time and effort went into preventing this bad thing instead of trying to make good things happen. It's way more fun to build stuff that you want people to use than it is to fight people being bad actors and trying to stop them. It ended up in an agreement with Microsoft where Microsoft paid Sun like $1.95 billion. But at that point, like say they had kind of slowed things down enough that they were able to come in with their own .NET and other internet strategies. As much as it sucked, I am really proud that we stopped Microsoft from forking the system and taking control of the technology.
So you talk about openness, Scott. I remember before we started Sun, I tried to buy a printer from Xerox to hook to the VAX, and they wouldn't tell me how it worked because they didn't want me to hook it to the VAX. People didn't want things to work together.
There was a lot of pressure for us to open source or at least submit to a standards body.
What we eventually decided, though, is we would create our own standards body because we couldn't trust the way things worked in these normal standards bodies. So we created the Java Community Process.
I'm Heather Van Cura, manager of the Java Community Process Program Office.
The Java Community Process was really formalizing the informal process that was used as Java was created, because essentially it was a technology that was created for working developers to use it.
This was trying to straddle something that was kind of owned and operated by Sun, but that otherwise treated Sun as more or less a peer with all the other members, the IBMs and the HPs and the Oracles.
The JCP was created to bring in more participation from industry, so anyone's welcome to join. It started just companies could be members, and then over time we also brought in institutions, and then finally formalizing the role for Java user groups.
When so many people rely on what's happening here and you've got so many interests at place, the guardrails that came in place with the JCP, they were really valuable. And even though there's a little bit of internal rebellion, or I felt like oh my God, I might want to rebel against it. I understood that this was actually good for the platform moving forward.
The Java community process is key to the success of Java because it enables the entire ecosystem to grow of multiple implementations, third-party libraries and tools and frameworks and everything you see that make Java really so much bigger than any one thing, even bigger than the language.
We have new tools, new ideas, and no rules. Except one, be open.
One of the things that happened early on is there was a push by the technical team to make the source code available for free to look at. You couldn't do anything with it. You couldn't build anything with it. You couldn't release a product based on it without a license, but you could look at it.
Sun distributed the sources of Java from day one, but they didn't provide a license that allowed anyone to do whatever they wanted.
For Sun itself, open meant interoperable, open standards, and that was really the place where they came from in their head. Whereas to the generation of us that were really participating in the web that was building and the open source movements, open meant open source, which is where you could actually not only have a spec and not only have interoperability, but you could take the software and improve it.
About half the code in Safari is this open source rendering engine. Some people have a problem with open source. We think it's great. We think it is great.
These two versions of open, they really pulled at each other through the entire lifetime of Java.
We didn't really start calling it sharing, but we've been talking about open interfaces forever, open systems for open minds or whatever. And we finally just said there's a simple word for what we do. We share.
The major problem that we had with open sourcing was not with the developer community. It was with the sort of industry partner community. It was pretty clear that there was quite a number of them who would just go crazy if we gave them a license to do whatever they wanted.
I was adamantly opposed to open sourcing it because I didn't want the platform to fork. We had spent 10 years keeping the platform from forking, and full open source would allow that.
The crowd that was against open sourcing, they really had a point.
How do you make money then if you're giving all this stuff free?
That's what my shareholders are asking all the time.
Okay, so we have a specification. We need a reference implementation. I started writing a very simple web server that became what was called the Java Servlet Web Development Kit. I mean, what a name. It was a really bad name. Internally, though, it was in a directory that I had called TOMCAT. I looked around at the web server world, and it was clear that the web server with the most mindshare was Apache. Apache was open source. Therefore, it followed that if we really wanted servlets to go as far and wide as possible, we really needed to get the reference implementation into open source and into Apache. So I had to make the case several times about why this would be really important. Every time I made the case, everybody kind of was like, yeah, you have good points. But we're really concerned that if we do this, then it's going to either create a precedent, or we're not sure how this works with the business model. And of course, all this work with the open source community proved to Sun, or showed Sun, that they really did need to be in the community working to push this stuff forward, or else the community would actually start moving on with their own world and leave them behind. In the end, TOMCAT didn't get open source purely because of the arguments that we made. The executives always wanted big announcements, right? Of course, you want some big news, you want something to splash, you want something to happen. And we were in a position where it's like, oh, we need a big announcement for Java 1. And I basically got a ping saying, okay, you're up. And they were like, really? We're going to do this? They were like, yeah, we want to work with Apache. We want to announce this on stage. We want to do this. And so we got to invite Apache up, and everybody was like, hurrah, Kool-Aid, yay! and the community took the news of it, and they were just like, this is great. TOMCAT really helped prove to Sun and the executives there that even though they had fears, very real fears about Java dissolving into chaos if they open sourced it, they were able to build some confidence with the open source community by these efforts that happened.
In the very late 90s, the powers that be in Java decided to dream up the J2EE specs to standardize the way to build enterprise applications.
The enterprise edition of Java really started from working with folks like IBM and Oracle and others to figure out, like, okay, how do we build big scalable transaction systems that can do all these incredible things? Servlets were like a small chapter, whereas J2E was like a book. You put all the specs and you put it together, and they actually published it as a book. And it's, it's this thick.
The programming model of J2EE was rather verbose. It mixed Java and XML.
It felt like vendors were trying to rubber stamp their technologies and bless them as specifications so that you'd be forced to buy them, and good luck trying to make them work together. It was just, it was very, very, very painful.
Many of us just took our experiences of influencing Corba and building Corba platforms to J2E. The problem was that we were building Corba for people who had been in the distributed systems arena for 10, 15, 20 years. They grew up with machine code and maybe COBOL or C and then into C++. When J2E came along, it was influenced very much by Corba, and it kind of did the same thing. It started to toy a little bit with some of the veneers to simplify things, but generally it was pretty complicated to build anything relatively simple in J2EE.
We have been told that, the tablets have been handed down with the software truths. How can I possibly be disputing them? I think, frankly, it can't really be described in any other way than as a disaster. Very large numbers of projects were failing, and there was a very, very real possibility that the promise of Java as a server-side technology would end. The genesis of Spring was my first book. I'd originally set out to write a book on this belief system of conventional J2EE, yet by the end of the year I discovered that I'd lost my belief. I used to joke it was a little bit like a high priest, writing a book about their religion and discovering that during the course of that they didn't actually believe most of the things they were supposed to believe.
And this book basically said the emperor had no clothes. It said what I had felt, which is that to write software in Java using the stack that was being proffered by the so-called standards was just way too painful, and it didn't make any sense, and we looked like fools trying to entertain that.
The book was published in late 2002. During that year, I wrote 30,000 lines of code that became the first version of Spring. Then people started suggesting improvements and suggesting that it should be open source and suggesting that they would be willing to participate. So it was clear that an open source project was the right place to take the code forward. And it was also clear that people really cared enough about this code base that they didn't regard it just as examples. They regarded it as something that they wanted to be able to use in production and help evolve into a truly robust product. Another project that was very important was HIBERNATE, which was an open source persistence technology that just worked a lot better than the spec-driven persistence technologies at that time.
Persistence is a fundamental problem in application development for the reason that programs are ephemeral. They need to be able to store their state somewhere. HIBERNATE came directly out of my frustrations of working with entity beans. I had a debate with my manager who was not entirely wrong. His point of view was, look, this is the industry standard thing. And my side of the argument was, well, yeah, but this is actually doesn't work at all. And so I was very keen, to try writing some code in open source and putting it out there. And look, the first versions of HIBERNATE were terrible. But here's the magic of open source that, people came back, you were able to, try this thing out for free, come back with all sorts of feedback, and, bit by bit, I managed to make it better and better, and, got contributors helping make it better. The growth of HIBERNATE and its usage was extremely explosive. It was a thing which just happened to come along at the right time.
Then Java EE came around and picked up some of the stuff that Spring did. So you had this dance between these technologies and frameworks and specifications that kind of drove them further and made both of them better.
We had this incredible ecosystem. There were different frameworks that were in play on the server side, and a lot of them complemented each other. A lot of them were in competition with each other. What we have now is born of all that incredible competition, right?
I think the overarching story of enterprise Java since 2000 has been the open source community succeeding where this top-down specification-driven approach failed. Had Spring not emerged, I think J2EE would have destroyed both itself and Java.
The shocker, even including to everyone in the team, came at the Java 1 conference where Jonathan Schwartz and Rich Green were up on stage chatting, and suddenly Rich says, oh, well.
I think it's at this point not a question of whether, but a question of how. And I think we're going to figure this out.
Repeat that again, Rich? I think you actually said something pretty profound.
And I'm sitting in the audience with some of my colleagues, and including the then vice president for Java at the time. We just look at each other. Oh, okay. And the following year was a mad scramble to actually make that happen. We had to comb through all of the source code for, all kinds of legal issues. A bunch of us engineers worked very closely with Sun's legal team to figure out, what's acceptable, what's not, what to look for, how to change things. It was quite a massive effort.
Sun probably decided, let's create the open source implementation that everybody can get involved with. If you've got every major vendor in the world contributing to one open source implementation, why wouldn't you just use that?
OpenJDK is very exciting. The energy that it's developing, the unexpected support it's getting from the free software community is quite awe-inspiring.
Looking back, I think Sun open sourcing Java probably saved the platform. I think if Sun had not open sourced Java, I fear that Java may well have died with Sun.
Sun has now open sourced pretty much everything, including the hardware. Can you describe what you think of Sun's strategy in this?
No, I think that's the theme that we had in the beginning, and it's good to see it coming around again.
After the Java 5 heyday, we went into a bit of a dark ages. This is when the dot-com bubble had burst. Sun's business was spiraling.
The internet bubble basically killed Sun. When the bubble burst, it lost 93% of its value. And I hadn't understood Sun was really highly leveraged. Even though it was building this great stuff, it was highly leveraged on pets.com version 3.
Hey, Poodles! Did you know that pets.com delivers food, treats, and toys?
Pets.com, because pets can't drop.
When they stopped getting the free venture capital money, they went under. And so Sun couldn't sell anything. And everyone said, don't care, and started building racks of crappy PCs running Linux. And Sun just couldn't play in that world.
During the 10 years between 2004 and 2014, the Java programming language wasn't making much progress.
There was a period of Java stagnation. There was like 5 years between major versions, and after a new release, you don't see a lot of innovation.
I was one of the biggest critiques of Java. I was that guy on the other side of the picket line, holding the sign, quit using Java, move away from it. And I think, sincerely, that Java deserved that criticism.
We saw a kind of revolving door of ill-considered directions for Java, the last of which was under Jonathan Schwartz, Sun's last CEO, who thought because Java was already installed on 1 billion desktops, the best thing we could do was to spam those people with ads.
It was a difficult time. I think a lot of engineers were frustrated and even worried about, projects failing to be delivered.
We were like a couple of hundreds Java developers in a Slack group that were discussing how can we do, what can we do.
We would often hear the comparisons of
Java's dead like COBOL.
And I always thought this was kind of funny because being the next COBOL, that's actually not an insult. COBOL's been around since the late 1950s, and it's still used today. The time between Java 5 and Java 8, for those of us at Sun, as the company was desperately trying to survive, were very painful.
The competing platform, .NET, was moving pretty fast, and C# that was initially inspired by Java and sort of branched off, that language progressed quite a lot.
The .NET platform and the C# programming language, these were very transparent kind of clones of Java, but with everything changed just a little bit so we couldn't complain about trademark or copyright. And they went off and executed on it and did a very good job.
A lot of people were sort of peeking over the fence and were being very jealous of all the goodies that people on the other side had.
Java as a language didn't seem to be moving forward, and other languages like, say, C# were moving forward.
Good evening. This is an extraordinary period for America's economy. We are in the midst of a serious financial crisis.
In the days leading up to the acquisition, there was a lot of apprehension in the air. We didn't know, is Sun just going to go out of business? If Sun gets bought by IBM, are they just going to kill Java or put it into maintenance mode, or who knows what's going to happen?
At the last minute, IBM bailed.
This is your world at 10. Now, Wall Street's down over 3%, but there's one stock that's shining despite this downturn, and that's the stock of Sun Microsystems. It's up over 36% today because it's found a new suitor in Oracle.
Larry Ellison rushed in there and said, I'll do it.
Well, it took a while, but Oracle and Sun are now one company. We're very proud of that. We're very excited.
I remember vividly when my wife pulled up her iPhone and showed me the headline in the Wall Street Journal.
When it was announced that Oracle was acquiring Sun, my own feelings were like, oh God, this is going to be bad.
I tell you, I was a little uncertain about Oracle's takeover.
IBM was certainly seen as more influential in Java than Oracle was. So our first concerns, I think in Red Hat, but maybe even wider, were why couldn't IBM have done that? And now here you've got a company that's really only known because of their database coming in, and how are they going to influence it?
I had some significant concerns, like if Oracle unopen sourced it and required everybody to go back to $10,000 a seat.
Then I looked again, I was like, okay, no, Sun got Java as open source. Java itself will be fine.
I never had any illusions of being like a benevolent dictator for life. That was just not me.
Well,
I left Oracle 6 weeks after the acquisition closed in 2010. I had sort of lost the ability to spend time doing what I love to do, which is fundamentally build things. I really felt like, the places where they were trying to get me to participate were the places where I would feel really uncomfortable. Working with parts of the organization outside of engineering was kind of like, jabbing myself with a cattle prod. Not exactly a fun time. I just didn't see a future there.
Are we going to close the technology up? What's going to happen?
James Sun has done a fantastic job inventing Java, expanding Java, opening up Java, giving Java to the world, and we're going to do more of the same.
To pretty much everyone's surprise, the acquisition of Sun by Oracle proved to be really good for Java.
When Sun came into Oracle, Brian Getz and Mark Reinhold were both in the team. They were senior leaders in the team. My general feeling was that the core of the Java team at that time were extremely solid and had very, very good ideas, but had spent the last few years trying to deal with this challenging economic climate, and that had been a real challenge for them.
Sun Microsystems had its strengths, but it was a very engineering-driven company. Oracle was run as a business.
They looked carefully at, well, what did we just buy? What do we want to keep? What do we want to get rid of? What do we want to invest more in? And about 6 months after the Oracle acquisition, the plan for Java was unrolled.
It was kind of refreshing to be in a place where decisions were made on a rational business basis, and when decisions were made, they stuck.
And they brought in excellent new management who both understood how to run a business and also understood the Java technology.
The Oracle-Google lawsuit was a fairly tricky thing.
In 2010, Oracle filed a lawsuit against Google for using Java on Android. It was an open question back then whether it's okay to copyright an API.
It stemmed from some misbehavior, shall we say, by a Google executive towards Sun. And Sun, kind of by nature, is not real litigious. We were pretty ticked off, but didn't think that a lawsuit was a productive thing to do. Once the acquisition happened, the Oracle folks, they decided to go after Google for the stuff that they had done during the Sun years. And it got really heated.
This legal case ground on for the better part of a decade. Eventually, the Supreme Court did rule that the Google reimplementation of the Java APIs in Android was fair use as a matter of law.
One of the challenges with Java itself as a language and the library with Java is that the first thing you do after starting a thread is learning how to limit it, how to make it synchronized. Whereas in Scala, you quite take an opposite approach.
By 2010, it was pretty clear that Java was stagnating and the tension in the community was building up.
Many people tired of Java and started to look around because more modern alternative languages appeared.
To me, it was frustrating because here is a language that's being used so widely that stubbornly would not change.
People were frustrated with the slow evolution of the Java language. People were frustrated with its verbosity.
Why should I be using Java when you have all these exciting languages that gave us so much power on our hands as programmers? When we did 7, it was really just about taking the work that had been done and trying to blow the cobwebs out of the release machinery and show that, we could actually produce a release and get it out there, and we knew what it took. 8 was the first version that was done soup to nuts under Oracle's leadership. And I think that actually sort of signaled to many people out there the beginning of a change.
Java 8, in my opinion, was our last chance to show that you can teach an old dog new tricks and that we hadn't just had a good run. We realized that it was kind of a make or break time. Mark made the bold decision of, it's finally time we're going to add lambdas to Java. Even though the fundamentals of lambda expressions was set in the 30s when Church wrote Calculi of Lambda Conversion and had been well established in numerous languages like Haskell and OCaml and Lisp, people were still afraid that lambdas were too exotic for Java. There had been a fairly contentious debate in the Java ecosystem about what the best way to add lambdas to Java would be. And there were several competing proposals and some actual pretty nasty interactions between the proponents of these various proposals. So you had some contingent who just wanted to throw sand in the gears. Then you had vocal contingents for several different approaches, each of which amounted to, you should do it like they do it in my favorite language. When the hubbub of that died down, we sat down and looked at, well, what are the pros and cons of each of these proposals and how do we want to go about doing this?
In the original strawman proposal for lambdas that I made in 2009, there was a fair amount of inherent complexity. But one of the great things that Brian Getz did was he figured out how to toss out a bunch of that complexity.
It's easy to say, oh, you should just copy this feature from my favorite language. But if you just did that, it would look terrible. You have to sort of reinterpret the feature through the lens of how would Java, imagine this feature. We knew the stakes were incredibly high, that in some sense, this was Java's last chance. There were so many ways to get this wrong. It could have failed to meet the technical goals of building more expressive libraries. It could have felt nailed on. It could have bifurcated the ecosystem into old Java and new Java. But we also had, a very vocal community where, surprisingly, there was a significant contingent in the community who thought we shouldn't do this. That somehow this was too bleeding edge ivory tower for Java. Java's a blue collar language. This is too complicated for Java developers to understand. So high stakes, hard technical problem, diverse community with diverse opinions, political challenges. It was pretty scary. And I came into work every day and asked myself, so is today the day I'm going to make $1 billion mistake? I've had the luxury of working with these new features for the last year and a half now, and I gotta say, once you try it, you're not gonna want to go back. It's a lot of fun.
I have to be absolutely honest about it. I had written off Java. I don't care about this language anymore. So the fact that Java was going to have lambda expressions, why do I care? But I had come from one of my international trips. I had a couple of days free. And I said to myself, let me take a look at this lambda. I don't think it's going to be that great, but nevertheless, I want to take a look at it. So I had downloaded it. I was programming with it just to experiment. And I played with lambdas and streams. And I remember literally standing up at my desk and telling myself, this is different.
The fact that lambdas is now part of the language, that's completely changing the way you will write any kind of code.
The excitement in the community was huge. It was one of the most rapidly adopted releases ever because there was something in there that people really wanted to program with tomorrow.
People have been pining for lambdas. You know how many people just wanted lambdas? That's all. Just lambdas. Give us the ability to not write 7 lines when we could write 1, It happened. It finally arrived and it was great.
I was so convinced at what I was seeing in front of me. That's what converted me from being maybe the biggest Java critique to the biggest evangelist of Java.
One of the things I love about it is they've added to the language while preserving compatibility. The fact that they were able to add them to Java without breaking that promise, just actually amazing. I give them so many kudos.
Lambda is just so sexy, it's unbelievable.
Sexy, yeah.
And Brian deserves all the credit he's getting for the great job that he's done.
Some have described Java 8 as candy with lambdas and Java 9 as medicine. with modules. Lambdas were exciting. They came with a Streams API, all this other stuff. It was a big leap forward in expressive power.
I hope that you have as much fun using Java 8 as we did building it. Happy hacking, and thank you very much.
To me, Java 8 was extremely important. It was a game changer in a lot of ways. Java 9 brought the concept of modules, and that is significant in its own way. But then the accelerated release of Java is another huge milestone.
We shipped JDK 9 last September. We shipped 10 this past March. We shipped 11 just 7 weeks ago, and we'll ship 12 next March, and so on, every 6 months, like clockwork.
The release management process that we had for the old release cycle was crushing because the cost of a feature not making the release was huge. It was going to be delayed 3-4 years. And so there was all this process around making sure we knew the state of everything all the time. And as you got into the late phase of a release, daily release meetings, which of course took time away from building features.
We were under a senior VP at the time who was great at tossing out aggressive ideas. And he said, "Nah, you should do 6 months." Huh?
The 6-month cadence was fairly controversial at first. And this was something that was purely management driven, where, George looked at what we were doing and what we were spending our time doing and said, there has to be a better way.
Changing to the 6-month cadence wasn't a decision that was taken lightly. Initially, it was scary. It was very different. Things had never been done this way. And I think people recognized that, there were a bunch of technical challenges to this. And then, of course, there's the market. How are customers going to like this? Will they like it? Will they accept it? There were a lot of people out there at the time who were very, very skeptical, but we could not go on, having these big bang releases every 4 years, right? The idea that a college student could go through their entire studies at college, never seeing a new version of Java is kind of crazy.
When you switch to a relatively short time box period, like 6 months, the downside of a feature not being ready is not so bad. It doesn't go out now, it'll go out in 6 months, it'll be fine.
If your feature doesn't make it, that's cool. You're on the next train. It's only 6 months later.
So by decoupling the development from the release, the features are taking how much ever time they need for their development. When a feature is ready, it can be released within the next 6 months.
It was another big breath of fresh air because we didn't have to have these long meetings anymore about, is this feature going to make it? Do we have to slip the release? What will the ecosystem think? What will our partners think if this release slips by another 6 months? Oh, we're doomed. What are we going to do?
It's a cinch by the inch, hard by the yard, right?
It was amazing how it changed the experience of development. In particular, the overhead of release went from crushing to zero. Our pipeline got so much better because now we do a mix of working on things that we're hoping to ship in the next release, working on things that we're hoping to ship 3-4 releases away, features that we're designing that we hope to, ship in 5 or 10 years.
Java is a language that's always moving to where the puck is going. It's always just ahead of the next frontier, and it's made it a very practical language for people who want to solve problems today.
What's the secret? Well, the secret is that we've always taken the time to think about the big picture and the long term. We don't act only as developers, that is, people who create things. We also try to act as stewards.
I think Oracle has done a great job stewarding core Java.
The organization that's there right now is really dedicated and really good. In the past several years, the stuff that they've been doing has been just great.
We'll always give advance notice before removing anything. We'll only do so when there's a very good reason. Compatibility remains one of the core values of the Java platform.
Mark Reinhold, who's been the chief engineer, he's kind of the glue that has kept the pieces together and kept the architecture sane. And Brian Getz has been this figure of incredible academic integrity in the evolution of Java, the programming language.
To be a steward of something is to do much more than just develop new features. A steward has to look out for the entire platform all the time. A steward also has to have empathy, be able to put yourselves in the shoes of a working Java programmer.
So core Java has not just endured, but it thrived. But that focus on the language proper meant that some of the other ambitions like J2, what was then in the very beginning called J2ME and J2EE, these things sort of fell by the wayside.
Oracle contacted Red Hat and IBM and basically said, we want to take all of the Java EE specifications, testing suites, and reference implementation, Glassfish, and we want to move it to a vendor-neutral foundation. We created MicroProfile over a year ago, moved it to Eclipse. We've seen a great groundswell in interest and participation since we moved it to Eclipse. Moving E4J to Eclipse, I think, allows these two big communities to come together and help to drive enterprise Java into the next decade.
The state of Java EE around the release of Java EE 8 was that it was stopping up. There was almost a year without any progress, and the community was very frustrated. So when Oracle at Java 1 that year announced that they were moving Java EE over to an open source foundation, the community was very relieved. We will be able to evolve this technology further.
This time last year, we didn't think this was going to happen. This was not something that we actually thought was a realistic possibility. To then have it happen probably is the biggest thing to happen to the extended Java ecosystem since OpenJDK.
I never had any doubt about Java EE thriving without a corporate owner, because by moving it over to a non-profit foundation as Eclipse Foundation, we have a vendor-neutral playing field, and it opens up for more corporations to participate. So rather than having one corporate owner, we now have a myriad of contributors.
We have an approach in the platform where we don't want to put everything into the platform, but we want to enable developers to build on top. So we've got to find the right building blocks, and the right building blocks for them to build the solutions that would be hard otherwise. We've got good at replacing the foundations of the house while keeping the house on top steady and stable. And that analogy, I think, applies quite closely to Project Loom, where we replaced the internals of how the runtime manages threads with very little API changes under the covers, and a concept around threads can either be platform threads or virtual threads. And you can use either or using the same APIs.
Virtual threads were a huge step forward in terms of concurrency. For a long time, people writing high-performance web frameworks had to use this reactive style of programming, which is incredibly baroque, very difficult to debug and monitor. With virtual threads, it's back to simple single-threaded code.
I often say that Java 8 made the programmers more productive. Virtual threads makes the programs more productive, meaning they're more scalable.
Virtual threads are one of my all-time favorite features ever added to the language, or indeed to any language. For most people, it can be a flick of a switch. It's just so good.
For people building solutions on top of Java EE, I think having,
By the second half of the 2010s, I think Java under Oracle had really hit its stride. Java today doesn't get the credit that it deserves.
25 years ago, the JVM was clearly not where it is today. And for some reason, people still kind of hold onto that history.
Seems to be something about human nature that people absolutely love straw men. And there is definitely a straw Java out there that people love to bash. Bad news, guys. It doesn't exist anymore.
Technology changes all the time, and Java has managed to change with the technology by continually innovating.
The power of Java is not just in the language, but in the community as well. You can think of Java as a table with many legs, and every one of these legs is supporting this table and thus is collectively making it stronger. It's a great language, it's a great platform, it's a great environment, but it's also a great community.
The community is crucial to the success of Java. It has been over time since the very beginning. You know, when we started out in the late 90s, it was very much companies and developers who worked at companies, but now I see it more as driven by individuals.
For me, Java user groups is the backbone of Java from a community standpoint. You know, right now we can say there's over 340 Java user groups around the world. There's estimates, depending on who you ask, of the total population size of anywhere from 10 to 14 million Java developers around the world. When you start reaching 8 digits, that's a big number.
The open source community is enormously important to Java. And I would even go to the extent of saying Java would not exist today if it was not for the open source community.
The strength of Java has always been the ecosystem, the open source libraries and tools out there that we take for granted, and they've always been there. And I think many of the things that we did in the Java community back in the days are now being reinvented in other communities, and we kind of look at them and say, hey, we had this 30 years ago.
Java is the passport to the world. I travel to so many places around the world today because I am interested in learning and interested in sharing details about Java. I have had friendship with people around the world because of this ecosystem.
I met my family. I have my family because I got on a plane to go talk to people about curly brackets and bytecode on the JVM. You know, it's just this incredible place.
One of the somewhat sad things about being an engineer, for most engineers, a goal is to be invisible, to not disrupt people's lives, to solve problems before people even see them. And so everybody is interacting with Java every day, all the time. You just don't know it. The scale of Java is hard to fathom for most people. If you've got a credit card in your pocket, there's a Java virtual machine on there. Every financial transaction you go, every phone call you make, everything that you do with a bank, the IT systems for most hospitals.
It's the foundation of the web systems of lots of trillion-dollar companies. Chances are, if you're using a web browser to order something online or interact with a company, chances are incredibly high that the code between you and the database inside the company is running Java.
Java's incredibly ubiquitous, right? We often talk about how there are more than 3 billion Android devices, and those are just the Android devices that have the Google services installed on it. You also see Android in your thermostat, in your refrigerator, in set-top boxes. And so when you talk about the billions and billions of devices and the way that you don't even know that Java is there, it's just a device that is stable, that works well, that is updated automatically, that has all of the applications and facilities that you would expect from a modern operating system. Java and its tools are really what brings it to that breadth of devices across the ecosystem.
Netflix has always been using Java and will likely continue to use Java. We have about 4,000 microservices all built on Java. And pretty much every system that we run at scale is Java. So that is basically like a perfect match for what we need to do at Netflix.
Looking forward, the project that I think is most exciting is Valhalla. The whole aim is to heal the historic rift in the language and the platform between primitive types and reference types. If we can unify those two, we can bring another leap in the expressive power of the language, perhaps more significant than what we did with Lambda.
Valhalla is about going back and curing that original sin of Java, which the division between primitives and objects. And it is a very deep cut through every layer of the platform. So it affects the way the VM lays out objects in memory. It affects the language, it affects the libraries.
Okay, this project has been going on for quite a while, about 6 years now. When it first started, Project Panama is rethinking how Java World interacts with the foreign world. The name comes from the Panama Canal, which was an investment put in to sort of find the smallest distance between two big worlds, oceans, to make commerce easier, faster, and cheaper. And that's where Panama comes from. The metaphor is to make the commerce between the Java world and the native world easier, faster, and cheaper.
Valhalla will give you value types, which gives you cache locality, and it makes things like matrix multiplications really fast, which is going to be huge for AI. And Panama is that bridge. It's that foreign function interop. It's already here. These things mean that Java is going to be really, really efficient, really, really lightweight, really, really scalable, and well-positioned for people who want to write these AI inference engines.
In Java, things sometimes take a little bit longer to evolve and get into the language. But that means that when a language feature comes to Java, you can really be guaranteed that it is very well thought through. While if you look at the last maybe 5-6 years of the Java language, it is actually becoming really nice and modern and just so elegant to look at and to write.
Java is already very well positioned to take advantage of AI. It's got a huge footprint in the enterprise space, and that's where AI is going to be. I'm convinced, although we'd have to prove it out, we could build a machine learning library like PyTorch, enabled by Project Babylon and Project Panama. Maybe Java's greatest impact is what happens in the future. We haven't seen it yet.
What excites me most about the future of Java is the unknown. Lots of things happen, and mostly the interesting ones are the ones you could never predict.
I think it's very possible that there will never be another blockbuster language like Java.
Java made programming fun again for me. It just got out of the way and let you get your job done.
Java proved to the world that you can make a virtual machine work in practice, work at scale, and that it actually changes the paradigm of programming quite a lot.
Just like all the great pieces of technology that we've worked on over time, at first it was revolutionary, then it was interesting, and then it just becomes part of the foundation.
We had this notion that Java would be ubiquitous. It should be on everything. Now there are billions of Java VMs out there now.
It took all of these good ideas that were already floating around in the ether, and it made them mainstream. It gave them to everyone.
Java is a language that showed us the power of the community. Java is the language that showed us the power of ubiquity. Java is the language that showed us the power of evolvability.
I have huge, huge respect for the core developers, the people who conceived of and built this technology.
What we have is a gem. It's a jewel. It's well constructed. It's proved its worth. It has stuck around all these years. Don't mess with it.
So much depended on luck. Being at the right place at the right time, meeting the right people at the right time, having the right ideas pop into your head at the right time. It's all God throwing dice.